last time we reviewed uh, completing the square. So if I had x squared minus 8x minus 9, is that a perfect square trinomial? No, it's not. Uh-oh, he's on his phone. Were they cute? Yeah? Okay, maybe it's worth it. So this is not a perfect square trinomial. Move that over. X squared minus 8x, we leave a space, equals 9. What number would go in here? Minus 4. And what's the number that completes the square? Add 16. But if I do that, I have to add 16 to the other side. And that equals 25. And we square root. And I get x minus 4 equals plus or minus 5. Add the 4. So x equals 5 plus 4 is 9. Negative 5 plus 4 is negative 1. Those are my roots. Now, I could have factored this, and it would have worked. But sometimes you run into a polynomial that's not factorable, which means that the roots are either imaginary or they're irrational. Okay. Well, that's a lot of work. And sometimes the work is really complicated. So I want a way to solve any polynomial, but instead of looking at a polynomial and then completing the square, what if I completed the square first and developed a method that would just give me the answers by plugging in numbers? So I'm going to take this quadratic. Will we? So will everybody agree that this equation represents every possible quadratic, as long as a, b, and c are real numbers? Okay. So I'm going to complete the square. Is this a perfect square trinomial? I don't know. I don't know what a and b and c are. Probably not. Okay. Now, one thing about completing the square, you can only do it when the leading coefficient is 1. If it's not 1, then you have to do a more complicated method that's really a huge pain, which is why we don't teach it to you. So I need to make this polynomial, this quadratic, have a leading coefficient of 1. What is the leading coefficient right now? It's a. Is a equal to 1? We don't know. It could be. Hopefully it is. But how can I guarantee that the leading coefficient is 1? Divided by itself. So I'm going to divide everything by a. Is that allowed? Will that change the graph? Yes. Will it change the roots? No. And all I care about are the roots. So I now have x squared plus b over a x plus c over a is equal to 0. Is that a perfect square trinomial? I don't know. So I'm just going to pretend that it's not. So let's move this out of the way. So x squared plus b over a x plus some number is equal to negative c over a. Excuse me. Okay. So what's going to go in here? Half of b over a. How do you divide a fraction in half? So let's look at 6/5 and let's look at 9 halves. How would I cut 6/5 in half? I would just cut the top in half, right? 6 over 5 cut in half would be 3 over 5. So if the numerator is even, you just cut the numerator in half. So this would be 3 over 5. But I can't do that over, I guess I could. I could say 4.5 over 2, but we like our fractions not to have decimals inside them. So how else can you cut a fraction in half? double the bottom. 9/2 is twice as big as 9/4, right? So to cut a fraction in half, you either cut the top in half or you double the bottom. So what should I do with b over a? Is b an even number? We don't know. Half the time it is and half the time it isn't. Well, and then what if it's a decimal? No. So I guess most of the time it's not going to be. So let's just double the bottom. So plus b over 2a squared. So what's the number that completes the square? B squared over, not 2a squared, 4a squared. So this is plus b squared over 4a squared. Am I allowed to do that? Yes, as long as I have to add it to the other side. So plus b squared over 4a squared. Now, I have two fractions with different denominators, so I need a common denominator. What's my common denominator going to be? We could do 8a squared. Is there a smaller one? 4a squared, right? So what does this fraction need in order for the denominators to be the same? It needs a 4a on the bottom. Can I just times the bottom by 4a? No, that will change the value. So I times the top by 4a. Why am I allowed to do that? Why am I allowed to times the top by 4a and the bottom by 4a and not change anything? What is 4a over 4a? 1. And all I'm doing is multiplying by 1. So I'm taking the fraction negative c over a and I'm changing its clothes, but it's still the same person, right? Just has a different set of clothing. And I don't want to lead with a negative, so I'm going to rearrange the fraction, and I'm going to say b squared minus 4ac over 4a squared. Everybody follow? Okay. Adam can't contain himself. Now what? How do I solve for x? So how do I get to the x? I have x plus b over 2a squared. If I was completing the square, what would I do? I would square root, right? So I square root, and on the other side, I'm going to square root. The square root of the whole thing is equal to the square root of the top divided by the square root of the bottom. Everybody agree? So the square root of 9 over 25 is the same thing as the square root of 9 over the square root of 25, which ends up being 3/5. Right? So I need a plus or minus because I did the square root. I square root the top and I square root the bottom. And that gives me x plus b over 2a is equal to, how does the top square root? It doesn't, right? So we write plus or minus the square root of b squared minus 4ac. What about the bottom? The square root of 4 is 2, and the square root of a squared is a. Okay, now what? So what do I do with this? I subtract that. And now those two fractions have the same denominator. So I get negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so at the beginning of this, we did x squared, I shouldn't have erased it, minus 8x minus 7, right? No, it was a 9. So here's what I did. Right? Now, I can do that for every single quadratic and get an answer. Or if you're lazy, what if instead of solving each quadratic individually, what if I write a quadratic that represents every single possible quadratic, and then I complete the square once? I will build a formula that will allow me to plug in A, B, and C. So, inside this formula are all of the steps for completing the square. And you didn't know that. That's where the quadratic formula comes from. So if you take the steps of completing the square and you perform those steps on a quadratic where you don't know the numbers, you will build a formula that will allow you to plug in A, B, and C. And that formula will do completing the square for you. And some of it you can see, right? This is b over 2 and then squared, right? That number is b over 2 squared. And then this number is b squared minus 4ac. It's all in there. It's a little bit hard to see, but that's all the quadratic formula is. It is the equation form of completing the square, and that's why it always works. So really, there are only two ways to solve quadratics algebraically. Either you factor or you complete the square. And quadratic formula is just complete the square, but it's in formula version instead of, we call this an algorithm, right? A series of steps that you do to solve an equation. That's an algorithm. And so you can either use the algorithm or you can turn the algorithm into a formula. And that's all the quadratic formula is. And now you know. What? Okay, go ahead. Let me hold on. I don't want to break the ears of anybody. So, let's try the quadratic formula and see if it works. X squared minus 8x minus 9. So A is 1, B is negative 8, C is 9. So 8 plus or minus the square root of 64. My recommendation is for b squared, you ignore the negative, right? If I type in negative 8 squared in my calculator, it's going to give me negative 64. How come? Right, my calculator follows order of operations, which says exponents come before subtraction. So your calculator is going to square the 8 and then subtract. So anytime you put negatives into a formula, the same is true of fractions, you need to put parentheses around it. Or just ignore the negative because you know it's going to square and be positive. Okay? So minus 4 times 1 times negative 9. So this becomes a 36. And that's going to be over 2. So 8 plus or minus 100. This is 100. Square root of 100 is 10 over 2. 8 plus 10 is 16 divided by 2 is 8. 8 minus 10 is negative 2 divided by 2 is negative 2. Or sorry, negative 1. Okay? So this process right here just completed the square. That's all that's really going on. Okay? Now, what if we get 8 plus or minus the square root of 72 over 4? Does 72 have any perfect squares in it? 4, 9, 36. So 36 is the biggest one. So what is the square root of 72? Well, it's the square root of 36 times the square root of 2. So that would be 6 root 2 over 4. Okay. These all share a 2. So 4 plus or minus 3 root 2 over 4. These all share a 2. Can I get rid of that? Can I divide out that 2? No. So the outside of a square root cannot cancel the inside of a square root. In fact, it's not really a 2. It's the square root of 2. It's kind of like half of a 2. But it's half of a multiplication of 2. So some of the answers are going to ask for the exact answers. This is the exact answer. If it wants the decimal answer, then plug this in your calculator, hit enter, and then divide it by 4. Oh, it would be 2. Thank you. Good job pointing out my flaws. Now I'm insecure. How did I ever graduate from college? 3 different times. Yeah. That's either a really good thing or a really bad thing. If you have 3 college degrees, it's either good or it's bad. Okay. This should be review. You guys can handle that.